All right, guys. So last week we left off talking about what? We talked about different stalker operations spread across the US. Today we're going to kind of continue that narrative. We're going to talk about within predominantly the tall grass prairie production system, and then within wheat, two different grazing management strategies that are commonly employed. Then we're going to talk about the impacts of pretty much different rates of gain during the backgrounder/grower phase and how that impacts finishing performance. Okay? Okay. And I am recording. All right. So, two main learning objectives. Yes. Okay. There you go. Mm. All right. Two main learning objectives. Okay. But they're multifaceted. So, know the different grazing strategies for wheat pasture. So non-graze out, where we're going to pull them off and harvest that wheat for grain versus graze out. Then know the different grazing strategies for warm season perennial pastures. Okay. Intensive early stalking versus season long stalking. Okay. All right. First off, a little bit about grazing management and its impacts on forage mass and quality. Okay. So as a plant matures, okay, so this is age at harvest, 14 days versus 56 days. As a plant matures, its yield on this y-axis increases. However, its digestibility decreases. So as that forage matures, it's going to have more above ground biomass, but it's going to have more fiber and especially more structural fiber content. And so it's going to reduce its digestibility for that animal. Okay. So classically, the optimal grazing time to maximize yield and digestibility is where these two lines meet, where they cross. Okay. All right. So grazing management is a spectrum. Okay. It can range from negligible management. Okay. If I have an animal and I just allow them to have full access to the whole pasture, okay, continuous grazing, that is still a management system, right? But my input is limited, okay? Or we can have, uh, so a couple of instances where we may have negligible management. We could have poorly managed systems, okay? Or we could have extensive rangelands. And I would say there's really uh, no real evidence that will show a big, significant benefit of implementing a rotational grazing system in these extensive rangelands. Okay. And by extensive rangelands, I mean big, large areas on native forages that have low stock densities, low stocking rates. Okay. So low carrying capacity. So some rangelands are so extensive that increased management is not beneficial. Okay. These systems typically rely more on low input costs rather than maximizing a given level of productivity. So even if you do implement a grazing management, the cost of putting cross fences in that large landscape is so great that it may offset any production benefit you see. Okay. So typically in extensive rangelands, so as you go more to the arid west, there is no real benefit, especially economic return benefit for implementing more intensive grazing management. Okay. And so we typically will continuously stock these systems. Also around the west, where we start grazing more federal lands, okay, the producer, the animal owner who is leasing those lands from the federal government, why would he want to invest infrastructure on land that he doesn't own? Right? So that's another consideration. Okay. Um, all right, and then we can have the other end of the spectrum of grazing management where we have intensively managed forage systems, where we have frequent rotations. That could be from daily or even twice daily, where we're allocating a strip of grass to these animals very frequently. Okay, and we're going to look at the New Zealand grazing system as an example of a very, just how intensive grazing management can get. Okay. These are typically more applicable to grazing dairy systems. Okay. We don't really see a benefit of allocating a new strip of grass every day or really frequently to beef cattle. Okay. And I rationalize this because for dairy cows, we're getting production values twice a day, right? We're milking them twice a day typically. Whereas beef cattle, we measure this production over a very long term. So maybe there would be a little bit of benefit to a daily rotation or strip grazing beef cattle. However, we don't really see it. Okay. So they're typically used in like New Zealand, Tasmania, Ireland, and then in European countries where they are actually grazing dairy cows. There's some grazing dairy cows in Missouri in the U.S., but other than that, you don't really see it, right? Okay. So, as you guys know, did my PhD in New Zealand. These pictures were taken from a grazing dairy study I did as part of my dissertation. Okay. So the New Zealand grazing system is typically based off of ryegrass white clover. Okay, these are perennial ryegrass pastures, and they're going to have less than 30% white clover in the sward. Okay, so highly dependent on this perennial ryegrass. Okay, we will allocate a new pasture, and they call that a break, each day. And so they will go out and they'll do what's called a pasture walk, which we will do in lab, and they're measuring forage mass very frequently. Okay. Then they calculate how much area do they need to allocate these cows to achieve a targeted intake, typically 18 kilograms of dry matter per head per day, with a 1,500 kilogram per hectare residual. Okay, so they are allocating the amount of area that's being given to these cows to achieve a targeted intake and a targeted forage height residual. So how much forage will be left when they move the cow to the next pasture. Okay. So, if we have 50 cows, our targeted dry matter intake is 18 kilograms per cow. Okay. Our initial forage mass is 3,500 kilograms per hectare. We want to have 1,500 kilograms per hectare remaining. So we have 2,000 kilograms per hectare available to graze. Okay. 50 cows times 18. They need to consume 360 kilograms of dry matter for that mob, that herd. Okay. So 360 divided by 2,000 is 0.18 hectares needed for that 50 head group. So 0.18 times 10,000 meters squared per hectare. So we would need to allocate an 1,800 meter square area to that 50 head herd. Okay, that's just example math. Make sense? Okay. They will do a pasture walk. They'll go through with their rising plate meter, measure forage mass across all their paddocks, and then they will put them in order of most to least forage mass. Then they'll draw a line on their pre-grazing target. So how much forage mass do they want in that pasture when they turn cattle out into it to graze? And they'll have that line go down here to their post-grazing residual target. So I think in this example, it's just over 2,500 pounds pre-grazing, and it goes down to 1,500 post-grazing. So if we were spot on where we needed to be, each of those pastures would follow that blue line. Okay. Anything above that would indicate a surplus in forage dry matter. Anything below that would be a deficit. Okay. So whenever you do this, you can start to kind of plan ahead. Okay. Okay, and this is called the feed wedge. Okay. So here we have an example where the next paddocks that we're going to start grazing are all above that target line. So we have a surplus. So now as a producer, they can start making decisions. Do I want to close off a paddock and harvest it for hay, right? And what would that, and you can look at what that would do to your feed wedge. So if we took this one out and harvested it for hay, then where does the rest of these paddocks line up on around our target line? Does that make sense? Okay. Compared to here, we have some that are above our line, then we have some that are in deficit of where they need to be. So as a producer, okay, I can start thinking I need to slow down my rotation. I need to keep the cows in these paddocks for longer so that I can allow these paddocks that are in a deficit to catch up. Okay, does this make sense? Okay, so this just kind of shows the very far end of the spectrum of how intensively management grazing can be. We're not typically doing this in the US, except for those few dairy farmers that are actually all from New Zealand that set up shop there in Missouri. Okay. Any questions? Cool. All right. Okay. As I mentioned, typically that grazing dairy system does not translate to added beef for grazing beef cattle. Okay. However, if we can increase grazing pressure and therefore reduce forage allowance, we can reduce diet selectivity by these cattle, and so we can make them more fully utilize the pasture resources that are given to them. Okay, so we talked about this before. Okay, increasing grazing pressure, increasing stocking density, reduces diet selectivity by these cattle. They will more fully consume the forage that's given to them. Okay. All right, so this study, Allison in 1982, looked at increasing grazing pressure. So this is kilograms of dry matter per animal unit per day. So increasing grazing pressure goes this way. Up has a higher grazing pressure. Okay? So a lower number has a higher grazing pressure. They used markers to measure grazed forage intake of these cattle. They looked at forage disappearance by looking at pre and post grazing cuts. Okay? And then they put total forage so they put intake as they expressed intake as a percent of total forage disappearance. At really low grazing pressures, their harvesting efficiency was around 53%. However, as they increased grazing pressure, more of that forage that disappeared was actually consumed by that animal. So up to 99% of the forage that disappeared from those pastures at the highest grazing pressure was actually consumed by the animal. So does that make sense? Fit with everything we've kind of talked about so far? Okay. So if we can increase stocking density so that we are increasing harvesting efficiency of these animals and we're making them eat more of that forage that is on offer to them, can we increase our stocking rate? So that would be the benefit of implementing a rotational grazing system, right? It would not pay to rotationally graze cattle unless you can increase pounds of animals out on that grazing that landscape to increase profit to the producer. Otherwise, they're just throwing money into a bunch of fencing. Okay? Does that make sense? Any questions so far? Cool. Um, okay. But as we've talked about, increasing grazing pressure will reduce average daily gain on a per head basis. However, it should actually increase gain on a per hectare basis because we have more cattle. Okay. Okay. Rotational grazing versus continuous grazing. I would say that there is a big disconnect between perceived benefits and experimentally defined evidence, right? So this Brisk published a paper in 2008, and they conducted a systematic review of the literature. Okay. So they basically compiled all the experiments that looked at a continuous graze system versus a rotational graze system, and then they summarized the findings. Okay, so that's what a systematic review of the literature is. Okay. Um, so continuous grazing was equal or greater than rotational grazing for plant production, and it was found to be that in 87% of the experiments. So that means 13% of the experiments actually showed improvement for rotational grazing. Okay, but 87, the vast majority of the literature found no benefit for plant growth. Okay, animal product per head in 92% of the experiments. Okay, so rotational grazings didn't increase average daily gain in 92% of the experiments. And then animal production per area in 84% of the experiments. So what isn't the literature of these published experiments doing, not comparing, right? Why do we have this perceived benefit of implementing rotational grazing that we're not seeing in the studies that were reviewed? Does anybody have a thought? Um, yeah, I mean, I guess we don't know from this summary here what those experiments did, how intensively did they rotationally graze. So that's not a bad thought. How long is the typical research project US in the US? Do you think many people are doing an 18-year experiment? No. And that's probably the type of time scale that you need to find these differences that are important, right? In terms of building soil organic matter, okay, increasing persistence of plant species in a community, right? Most grazing studies are done over a 3-year period. Why is that? Anyone want to guess? Graduate students? Funding. The typical grant life is 5 years. So for you to be finished up with your write-up, you need to have your data collected in like 3 years because you need 1 year to basically plan. Okay. So, yeah, I would say that's the big limitation of the research that would have been reviewed is that it takes a long time to measure long-term impacts on soil health and long-term impacts on plant communities. Okay. And so obviously showing a benefit of rotational grazing in terms of economics is likewise going to have that issue. Okay. Most people are kind of switching from just a mere prescribed rotational grazing where we have set defined paddocks and we are allocating these animals in for a prescribed length of time. Okay. And they're going more towards this adaptive grazing management. Okay. So this is all based off of building flexible stocking rates to where we can set how many cattle we're grazing in a given area based off of available forage mass. Okay. So the typical producer is going to set their carrying capacity, their perceived long-term sustainable stocking rate based off of what they can stock cattle at on a good year. Okay, so in a poor rainfall year, when there's less forage mass, they're going to be overgrazing. Then they're not going to have enough forage to support their animals, and then they're going to have to destock. So it's kind of led to that cow cycle that we've seen in recent years, right? Whereas if I'm an adaptive manager, I'm changing our grazing resource needs based off of the grazing resources that are available. Okay. So they also state that you need to be prescriptive pasture rotations as opposed to planned. The next bullet really kind of outlines the difficult thing whenever we're talking about from a research sense on adaptive grazing management. Okay. It's hard to set treatments, right? So if I was going to do a long-term grazing study comparing continuous grazing versus adaptive management grazing, how would I set that treatment? And would someone at a different location make the same decisions that I'm making? Right? So it's very hard to have repeated results. Okay. I think that the most important things for a producer is to just have some kind of written plan. Okay. To incorporate some thought into their grazing management. And the U.S. Roundtable for Sustainable Beef would also agree with that. And that's why their commitments are not around getting so many acres into adaptive management grazing. Their commitments are into getting 385 million acres covered by a written grazing management plan by 2050. Okay? Kind of a vague goal, right? Because what if a producer just writes down, I have no plan, or I'm going to continuously stock, right? That is written, and their plan's not to plan, so it is what it is. Okay, so we've talked about this quite a bit, right? Now we're going to kind of get into different grazing systems that exist that are relevant to the stocker industry. Okay, we've talked about this quite a bit. USDA NASS estimates, this is from last year, stated that 74% of calves were born between January to June during those 6-month periods. So that means 26% were actually only born between July and December over those 6-month periods. Okay, this top graph defines different calving seasons. Okay, so if I'm a spring calver, I need to breed May through June so that I can calve February through March, and then we'll wean those calves September through October. Okay, that's what most people are doing. If I am a fall calver, I need to breed December through January so that I can calve September through October, and then we're aiming at weaning April through March. Okay. This here is data from the USDA NAHMS. So that's the National Animal Health Management Survey, I think. And it grouped up the percentage of calves that are born, this from 2017, by month. Okay. So you can see most of those calves are born February, March, April. Okay. You have a little bit of another increase here during fall calving, but the vast majority of cattle are born during those spring months. So about 56% of calves were born in February, March, and April. Okay, so why do we have these calving seasons? Most of our forage systems are based off of warm season perennial pastures. So it matches cow requirements with forage quality and quantity. So once that cow calves in spring, she's going to go into lactation and have a real increase in energy requirements. So calving in the spring, peak energy requirements are in that early spring period. That's when these warm season grasses really start to take off. Does that make sense? Okay. And because of that, it requires less feed inputs. Now, the other benefit of spring calving, if you're not calving in January, like a lot of people around here are, right, is you kind of get out of that cold period. You don't want young calves when you have a real bad cold spell come through. Okay, it was first moved back from New Zealand in December 2020. Does anybody remember February 2021? What happened? Yeah, crazy freeze, right? So I know producers in Blackwell, Oklahoma, who had a 30 cow operation lost 28 calves, right? So don't want young calves born in cold weather, okay? It seems like our cold weather is getting later, but I know most people in Oklahoma and northern Texas are still calving in February. I think it's time to start bringing that back a little. Okay. Any questions? Cool. Most of our producers in Oklahoma and North Texas are calving in February because they want heavier calves at weaning to then be placed on wheat. Okay. So one thing I want to do today is show you, so don't get too stressed out when you see these graphics, but I want to show you different calving seasons and how different management strategies to that calf can impact when that animal is going to be harvested. Okay, just to show how the stalker and backgrounder play a role in spreading calving or spreading inventory, right? So this is that inventory role of the stalker operation. Okay. So let's say we have a spring-born calf. I think our average birth weight in the U.S. is 80 pounds. We're going to wean in October. So at about 6 to 8 months is typical weaning age. Typically, I think the average is 7 months. BIF standardizes calving or weaning age at 205 days. So you'll hear people, especially in research, talk about their 205-day adjusted weaning weight, right? Because you need to account for that when, if you just don't want one animal to be heavier just because they were born earlier, right? So they adjust weaning weight to that 205-day standard weaning date. Okay. So that puts us sometime around mid November at 500 pounds. Okay. Ish. There's obviously going to be a wide range in weaning weight, which will impact when that animal actually gets marketed, right, or slaughtered. Okay. If I do fall winter grazing on wheat pasture, so this is an example for winter wheat, okay, assuming a 3 pound per day for 90 days, okay, that animal's going to add 270 pounds during that fall winter grazing period on winter wheat. Okay, so that puts you at March 1 at 770 pounds. So then that animal can go straight to the feedlot, where, rough guess, they're going to gain 3.75 pounds a day. Okay, it'll take 181 days on feed to add 680 pounds and be finished at 1450. Okay, so that animal born in spring will be harvested on August 29th, will be 16 months old or about 471 days old. Okay, so we'd call that like a short yearling. Okay. Now, here in March, we can make a decision. We can go through spring grazing at another 148 pounds during that time at 2 pounds per head per day. That would put that animal entering the feedlot at 918 pounds on April 30th. Okay. Assuming again the same average daily gain, that animal would gain 532 pounds over 142 days to be finished at 1450. Does that make sense? You guys are following? Okay. So just by going through a spring graze out, we took an animal that would have been finished in August 30th to now late September. Okay. And instead of 470 days old, it will be 506. So about 17 months. Okay. We could also take fall-born calves, 80 pounds, wean them at 4 to 6 months in March, gain 420 pounds, that they're 500 pounds beginning of March, and then enroll them directly into that spring graze out period. Okay, so that would be destalking cattle during early March and then bringing in a new group of cattle for spring graze out. Okay. Over that spring grazing period, assuming the same average daily gain, would gain 148 pounds. So that'd be April 30th, weighing 648. It would take that animal placed in the feedlot at 648, 214 days to gain 802 pounds. They would be finished November 30th at 1450. Okay, does that make sense? Okay. So we mentioned just briefly first hollow stem. That is the main uh, uh, thing to consider when you're deciding when it's time to pull calves off if you want to use that wheat for dual purpose. Okay? So, first hollow stem, this is a wheat plant. As a producer, you'd walk out to your wheat pasture, grab 10 different plants. You'd split that plant down the middle, and then you would assess the different distance from the, what do they call that, above ground, the crown? Is that the crown? God, I don't remember. I'm not an agronomist. Okay, that is the emerging seed head. Okay, y'all see that? So, colloquially, if it is the width of a dime, it is now high enough for an animal to graze that seed head, that emerging seed head, off of that plant. Okay? Anything below that, it is too low, too close to the ground for cattle to effectively be able to graze. Once that seed head is grazed, that plant can't produce wheat. It's not going to develop a new seed head. Okay? Does that make sense? So, this area is called the first hollow stem. So it is that emergence of the seed head up the developing stem. If you guys have ever seen wheat, you know that the straw is hollow. So as that seed head goes up the stem, it leaves a hollow, what the hell is that called? Stem. Okay. Okay. So for dual purpose wheat, we want to plant in October. We want to turn cows out to graze starting around mid-November, ideally, typically trying to target right around Thanksgiving. Okay. We want to graze until forage reaches first hollow stem. That typically is occurring mid to late February. Okay. Then we need to remove cattle. Okay. First hollow stem occurs when the hollow stem is 1.5 centimeters tall. Okay, so about the width of a dime. Okay. This shows the reduction in wheat yield as you graze days past first hollow stem. Okay. So days past first hollow stem here on the X, percent reduction in grain yield on the Y, and then the different lines correspond to a favorable growing condition, so warm and wet, right? Average growing condition, and then unfavorable growing conditions. So, grazing past first hollow stem, you can reduce grain yields by 1% per day in unfavorable conditions to 5% per day in favorable conditions. So it's going to have a huge impact over a week on your total grain yield. So over a week in unfavorable conditions, we can reduce our grain yield by 35%, right? Does that make sense? Okay. Graze out wheat. We've mentioned this. Due to spring flush, which is that rapid period of forage growth during the spring as warm temperatures start coming, okay, we can double the stalking rate on a given area. Okay, we will typically graze this pasture until forage allowance becomes limiting. So our forage allowance becomes less than a pound of forage per pound of body weight. Okay, on really favorable years, if you don't have enough animals grazing that area, the wheat can actually get too mature before you lose forage allowance. Okay, does that make sense? Okay. Typically, graze out wheat will play out by the end of April to early, even early to mid-May, and it's going to depend on growing conditions, so temperature and precipitation. Okay. So, important things to consider. You don't have to make a decision whether you're going to harvest that wheat for grain or graze it out until first hollow stem. So you can conduct a cost-benefit analysis to see, would I make more money if I graze these cattle? Would I make more money if I harvest this for grain? Right? And that's going to be driven by the value of the steer that you're going to sell. So the value of that added gain during the spring graze out period compared to the value of that grain that you would harvest. Does that make sense? Okay. So another thing, you can sell cattle grazed that are grazed in the fall and winter, and then buy in a new set of calves for the spring graze out period. You can keep the calves that grazed in fall/winter. You can double the stocking rate by taking half of that area, so fencing off half that area, bringing all those animals onto half, and then you can harvest that other half for wheat. Okay. Or we can purchase new animals to double our stocking rate. So graze out the whole area, bring in new animals to double our stocking rate for graze out. Make sense? Okay. So this is just kind of quick math to look at the break-even point based off of dollar per bushel wheat price as it and it's also going to depend on the value of that steer. Okay. So first, here we have steer sell price on the x-axis. Here we have profit difference, where 0 would represent the break-even. These negative values mean we lose money by not harvesting that grain. Okay. So do regression on these 3 points at different steer sell price. Find where it crosses 0, and that is your break-even for these $3 per bushel price of wheat. Okay. Then you can do another regression across those where the line crosses 0 on the x-axis. So your x-intercept based off of that dollar per bushel wheat, and you arrive at this equation. Okay. So you could use this equation, plug in the value of that wheat grain, and then determine what dollar per pound stocker break-even sell price would be. Okay. Does that make sense? Okay. Okay. So in this scenario, they assumed 35 bushels per acre wheat yield. So I told you that's pretty indicative of like Oklahoma, northern Texas. We are assuming that we're going to sell 640 pounds if we use for dual purpose. So if we're going to remove cattle off of that wheat pasture, this analysis is assuming we're going to sell 640-pound steer. Or if we're going to graze out, it's assuming we're going to sell them at 800 pounds. Okay. Then importantly, this scenario would change as those assumptions change, right? So if the weight of the steer I'm selling at dual purpose changes, but this is kind of held constant, it's going to change that break-even point for your dollar per bushel. Does that make sense? Okay, but it's just an example. I've did something similar with fat inclusion in a finishing ration. Like at what corn price does it break even to include fat, supplemental fat in a finishing ration or not? So, okay. Now we're going to go into season long versus intensive early stocking. Okay. So in this scenario, we have a fall-born animal, assuming 80 pounds birth weight, going to gain 420 pounds, wean mid-April to early May at 500 pounds. In the intensive early stocking phase, it would gain 2.08 pounds a day for 90 days. So at the end of the intensive early stocking would be 7's June or July. July. So it'd be July 15th, weighing 688 pounds, placed in a feedlot, would need to gain 762 pounds over 203 days to reach 1450. So this steer would be harvested February 3rd at about 500 days old, or which is about 16 months. Okay. Or after weaning, we can make them enroll in a season-long stocking, okay, where they're going to add 280 pounds. So they're going to gain a little less because they're grazing in that late summer as well. That late summer is going to have lower forage quality. So I assumed 1.83 pounds per day for 153 days. So at the end of the season long stocking, that animal will weigh 780, be placed in a feedlot September 15th, the day before my daughter's birthday. Then we'll gain 670 pounds over 180 days. So that at 1450, we are now March 12th, 532 days old, about 17 months. Okay? So you can see how a producer makes different decisions, and it's going to change when that harvest date for the same group of calves born at the same time. Does that make sense? So that's that inventory role of the stalker backgrounder. Okay? Okay. Here's another example of a system that we could adopt. Okay? Spring-born cattle. Okay? They are gaining 420 pounds to 500 pounds at weaning, October 15th. So we could overwinter these animals on dormant warm season pasture, okay, or on crop residues, or feed them conserved forage, targeting a low cost of gain, real low growth rate, just to get them overwinter into a warm season grazing system. Okay, so after that period, we're only targeting 1.25 pounds a day for 150 days. We got these animals that were born in the spring to 687 pounds starting April 15th through May 1st. Okay, now we can start grazing them in a warm season pasture system. Okay, we carry those animals on intensive early stocking, assuming the same average daily gain as the previous one. Gain 162 pounds, July 15th, weighing 850, will only take 160 days. They will be harvested at 1450, January 14th, 600 days old, about 20 months. We would call that a long yearling. Okay? That makes sense? Or they can go season long, gain 237 pounds, placed in a feedlot at 924 pounds on September 15th, gain 526 pounds in the feedlot over 140 days, 1450, February 2nd, 643 days old, about 2 years, right? Still consider that a long yearling. You guys follow? Okay. Now we're going to go into the differences of season-long stocking and intensive early stocking, talk about some of the advantages and disadvantage of the two, okay? So in this example, we have 200 acres of land, okay? Season-long stocking, we will graze beginning of May, stop grazing end of September. For intensive early stocking, we're going to graze beginning of May and end July 15th, okay? So total grazing days for season long stocking is 150. For intensive early stocking, it's 75. Number of steers in our season long stocking, we can only do 50. In our intensive early stocking, we can do 100. This is just one example, right? These stocking rates, these numbers of animals can change. Okay. So our stock density in acres per steer, season long stocking, we have a 4 acres per steer stock density. In intensive early stocking, we have a 2 acres per steer stock density. However, our stocking rate, which has that time element, is the same at 28.1 animal unit days per acre, okay, for both. So you have, in the season long stocking, you have half the amount of head, but for twice the amount of time, compared to your intensive early stocking, half the amount of time, twice the amount of head, so that your stocking rate does not change. Does that make sense? Okay. And over there just shows the math example of how to do that. Okay. So Smith and Owensby. Owensby was out of Kansas State for a long time in charge of the Reynolds Research Ranch there just south of Manhattan in this tall grass prairie ecoregion. Okay. But he did a lot with intensive early stocking. Typically, intensive early stocking has greater average daily gain, pounds per head per day. Okay. than season-long stalking. Okay, this is driven by you're only grazing those animals during that earlier summer period where forage quality is going to be much higher compared to the season-long stalking, where you're going to graze those animals early summer, and they'll have comparable average daily gains, okay? But also in that late summer, where average daily gains can be suppressed because forage quality gets lower. Does that make sense? Okay. All right, season-long stalking had lower average daily gain during the second half of the summer, so that it makes it so that season-long stalking has lower average daily gain on average over the whole grazing period. Okay. Season-long stalking has greater total gain per head. So each individual animal is going to have more weight gain in season-long stalking than intensive early stalking. That should make sense. Even though they have a lower average daily gain, they're out there for about twice as long, right? Does that make sense? However, intensive early stalking will have greater gain per acre than season-long stalking. You have double the stalking rate, and you're really maximizing that period of time where they have twice the amount of average daily gain. So, or not twice, but an increased average daily gain because of increased forage quality. So that's one benefit of intensive early stalking. Your gain per acre will be higher. Okay? Okay. Now I'm going to set the stage for another benefit of intensive early stalking. It is very common for rangelands to be burned early spring. Okay? These folks out there have a culture built around fire, right? You'll have neighbors that go and help each other. So the Indians used to do this before the colonials came over, right? They would do this in Australia too. The Aboriginal people would prescribe burn areas to increase the forage quality of that new growth so that they would encourage the animals they hunt to congregate there. So very similar to what we're doing now, we will burn these pastures, one, to control for weeds, invasive weeds, which didn't evolve in these burning landscapes, but two, to increase forage quality. Okay? So, about 2 million acres of rangeland, so this is each year. These are the counties of the Flint Hills. Okay, you'll see some in Oklahoma. Each year, about 2 million acres in the Flint Hills are burned. Okay. Okay. Typically, you're burning February 14th to April 29th. Okay. So I've already said that. Native rangelands, these native grass species, they evolved around a burning landscape. Native Americans used to do it, a prescribed burning. Also, you could have lightning strikes, start a fire. So it's just a very common occurrence that these plants, these native species evolved around. Okay? So burning has a lot of benefits. Okay? Chiefly, it improves forage quality. Okay? You burn that residue, you allow that above ground sward that grows to be fresh growth. It's obviously going to be a lot higher quality than a sward that contains dormant thatch from the previous year. That makes sense? Okay. So in 1988, this study was done. They looked at the impact of burning versus not, and then timing of burning and its impact on forage quality and for rate of passage, ruminal rate of passage. Okay. So burning increased rate of digestion by 14 to 20%. Okay. Increased digestibility by 11 to 22%. And whenever you have a higher digestible forage, how is intake going to respond? They're going to eat more. So they saw that dry matter intake of burned was increased by 5 to 11%. Higher digestible, greater intake, they saw a 5 to 11% increase in average daily gain. That makes sense? Okay. Burning reduces invasives. Okay. Said this a couple of times now. These native forage species evolved in a burning landscape, so they are adapted to recovering from burning. Okay. These invasives, predominantly woody invasives like western red cedar or different juniper species, they did not evolve in that same environment. So, common to burn these native rangelands to control especially woody species, okay? But to get an effective kill rate, so this is probability of survival, these panels are height of that cedar, okay? To get an effective kill rate, you need to burn them when they're younger, okay? So got a real effective kill on these cedar trees when they were less than a meter tall. However, as that cedar tree gets taller, the probability of survival goes up. Does that make sense? Okay. That was published by Nippert, 2021. Okay. So starting to get into some of the negatives of burning. Obviously, air quality. Burning creates smoke. Surprise, surprise. Okay. So this burning releases what's called PM 2.5. So that's particulate matter that is less than 2.5 micrometers in diameter. So that is small enough that when you inhale it, it can be absorbed into your lungs, right? So also burning increases ozone, which is great for when it's in the atmosphere, but down here where we're breathing, it can be a detriment to our health. Okay? So ozone and PM has obviously respiratory issues, coughing, wheezing, reduced lung function, reduced resistance to infection, asthma, inflammation, heart failure, cardiac arrhythmia, hardening of the arteries, stroke, heart attack. And I think they have linked people that live in these areas to some of these negative health effects. They have an increased likelihood of developing these negative health effects because of this PM 2.5 and the ozone that's being produced from burning. Okay? That's not good. Okay. But they're trying to manage that. They've developed these smoke management plans where they will say, based off of wind and climate, when people can burn and how many acres in a given area can be burned at once. Since they've implemented these, air quality concerns have really decreased, but a lot of these plans are largely voluntary. But the producers in that region have pretty well accepted them. Okay. Any other questions about that? 17 minutes, right? Okay. So burning is improved by intensive early stalking. So that's a benefit of intensive early stalking. Since we pull calves off mid-July, they have that later part of the summer to accumulate forage mass that will then go dormant through the winter and then can be burned, increases the fuel load of that land to be burned in early spring. Okay. Also, it increases the uniformity of the stand of that dormant forage across the landscape, so you can increase the evenness of the burn that you get. Okay. As we saw in that figure of the red cedars, weed control is more effective whenever it gets closer to the weed that you're trying to control. Right? So if you have a more uniform spread of this dormant forage, that will create an even burn, okay, your outcomes will be better. Okay. More fuel increases intensity of the fire. This results in greater animal performance and better weed control. So here we have, these are percent increase for the first versus the second one. So intensive early stalking increases gain per acre by 19% versus season-long stalking. Okay, comparing two season-long stalking, one with fire, one without, burning and season-long stalking increases gain per acre by 26%. Okay, here we have intensive early fire stalking with fire versus season-long stalking with fire. We see an increase in gain per acre of 37%, which is higher than without grazing or without burning, right? So intensive early stalking responds better. The response you see when intensive early stalking versus season-long stalking is higher when you also incorporate a burn. Make sense? Okay. So let's look at the effects of intensive early stalking versus season-long stalking on feedlot performance. Here we have a study that was done over 2 years, 1991, 1992. On average, season-long stalked cattle had 11.4% greater feed intake. That should make sense. Their average placement body weight would be higher, right? So their average body weight while they're on feed is higher. Larger animals are going to eat more. Okay. Reduced average daily gain by 0.19 pounds per day. So this is average daily gain over the feedlot. And season-long stalking increased feed to gain by 17%. Higher feed to gain is worse. So it reduced feed efficiency by 17%. Okay. And season-long stalking had 78 pounds greater placement body weight. Okay. So why would we expect feed efficiency and average daily gain to be reduced in season-long stalking versus intensive early stalking? Okay. Larger placement body weight means average feeding body weight will be higher for your season-long stalking versus your intensive early. Okay. Cattle are in a feedlot at different times too. So maybe the season-long stalking maybe the intensive early stalking cattle will be out of the feedlot December, January before bad weather, cold weather hits. Cold weather increases maintenance energy costs. Okay. But the big thing is the season-long stalked cattle will have larger gastrointestinal tracts. Okay. They'll have larger livers and larger heart. So those three tissues are the big drivers of maintenance energy costs of the body. Okay. So larger GIT, larger liver, larger heart at placement in the feedlot will increase maintenance energy costs for season-long stalked cattle versus intensive early stalked cattle. So the gastrointestinal tract itself only accounts for about 8% of live weight of the animal, but it accounts for about 45 to 50% of oxygen consumption. Okay, and oxygen consumption is directly related to energy use. Does that make sense? Also, larger gastrointestinal tracts for season-long stalking will have more protein turnover, right, which is going to increase protein requirements for season-long stalked cattle. All this kind of gets to explaining why season-long stalked cattle will have a lower feed efficiency, so a higher feed to gain than intensive early stalked cattle. You guys are following? Okay, just a picture. Here we have a hot carcass weight. There they're removing the gastrointestinal tract. So 8% of the body weight, large proportion of that animal's energy use for maintenance. Okay. Summary of the advantages for intensive early stalking. Greater gain per acre during the grazing season, greater feed efficiency in the feedlot. So I want you guys to understand why that occurs. Okay. Then it allows for forage to accumulate, okay, which increases fuel load in late summer if pastures are to be burned that following spring. Okay. Disadvantages. So there's really kind of one. If you have a year where it's slow to start warming up and you delay when that warm season pasture will start growing, you may have to delay your grazing season, which would shorten your total grazing period. That makes sense? Okay, 11 minutes. All right, warm season perennial pasture. Here we have data from Gunter and others in 2005. That's where I pulled these average daily gains. So here we have calves that are born in the fall, 80 pounds, weaned at 7-ish months, gained 420 pounds to be 500 pounds at weaning, mid-April to early May. Season long stocked, typically on warm season perennial pastures. Here I'm talking about like Bermuda grass or other tropical warm season species. So at the end of the grazing, they'll weigh 710 pounds. They'll enter a feedlot, need to gain 740 pounds. That's going to take 197 days so that they finish at 1450 on the end of March. Okay, at about 18 months. So a short yearling. Okay. This is an example of a backgrounding. Okay. So same animal that's born. This animal could be born, backgrounding operations in confinement, they can occur any time of the year. So this animal can be born at any time. Okay. Born at 80 pounds, weaned 500 pounds. So we can have a slow target rate of gain at 2 pounds per day. We can have an average rate of gain at 2.5 pounds per day, or a high rate of gain at 3 pounds per day. So to gain 400 pounds so that they get placed into the feedlot or transitioned to the finisher diet at 900 pounds. In the slow rate of gain, it's going to take 200 days. In the medium rate of gain, it's going to take 160. And in the fast rate of gain, it's going to take 133 days. Okay. Transition to the finishing diet. All of these need to be gain 550 pounds. All is going to take about 147 days, even though in reality, these guys will have a lower average daily gain because they're going to be more fleshy. So for our slow rate of gain in the backgrounder phase, it's going to take, that animal will be finished at 547 days old. For the average, 507. For the fast, 480. Okay, so again, just showing how rate of gain that you're targeting in your backgrounding phase can create animals that are harvested at different times. Okay. Okay. Talked with my buddy, consulting nutritionist. He consults in the Midwest and Texas Panhandle, Southwest Oklahoma. Okay. In northern backgrounding yards, they're going to target a 1.8 to 2 pounds average daily gain. Okay. They will feed these animals 120 to 150 days, depending on what their initial body weight was going into that backgrounder phase. Okay. They want a lean 800 to 900 pound animal that they're going to start transitioning to that finisher diet. Okay. Lean animals going to finish. This is especially important in the Midwest, where they're feeding a lower starch containing grain and high moisture corn versus steam flake corn in the southern plains. Okay, does that make sense? Okay. They will finish these animals typically heavier than what we will in the high plains. So 15 to 1650. I bet this is even higher today. Okay, this called him last year about this. Heifers will be a little lighter, 1400 to 1500. So they will carry animals to a heavier finished weight in the Midwest than what we will see in Texas, Panhandle, Oklahoma, Southwest Kansas. Okay, people in that area will refer to these cattle being finished in the Midwest as jumbos. Okay, what they're targeting, cheap cost of gain. That's why it's really important for them to have a lean animal being transitioned to the finishing diet, because they will have a higher feed efficiency. So their cost of gain is going to be lower. They want to sustain the value of gain because there are next to no hot carcass weight discounts that people are experiencing today. Okay, so the heavier you can get them leaner before you start transitioning to the finishing diet, the higher endpoint body weight you can carry those animals. So they really want to try to maximize that total final body weight that they're selling. Okay. They will feed higher quality cattle than what they do in the Southern Plains. Most of these are going to be 100% Bos Taurus. A lot of these are going to come from a known calf ranch of origin. They're going to be predominantly Angus. They're going to be pretty gutty. They have the propensity to eat a lot of feed. Okay. Okay. Then they're also the cost to replace these cattle is going to be high, just in general, no matter where you are, but even higher for them because they're higher quality cattle. Okay. Southern feed yards, they're going to target a faster rate of gain, 2.5 to 3 pounds a day. Okay. 100 and 150 days, again, depending on what that initial body weight was. Typically, these backgrounders are starting them on their backgrounding diet 450 to 700 pounds. So Jarrett, my buddy, said backgrounded cattle will receive a discount even if that backgrounding yard doesn't get them too fleshy. And I have some data that I'm working on for Plains Nutrition Council that would kind of support that even that the impact of rate of gain in a backgrounding yard has a larger impact on finishing performance than rate of gain in a pasture system. So these cattle will just be less feed efficient if they were grown in confinement on a backgrounding diet than if they're grown on pasture. I don't know why. Okay, but he said some cattle buyers can smell the silage on these animals. So you just visually, you can't tell, like me or you couldn't tell, but these cattle buyers are so experienced, so dialed in, they will know if that animal was grown in a backgrounding yard versus a pasture. Okay. We are typically finishing animals to 1,300 to 1,450, and we're feeding lower quality cattle. Cattle from the southeast, used to be cattle from Mexico, more Bos Indicus influenced cattle will be fed in Texas and the Southern Plains. Does that make sense? Okay. So I think we will start this slides later, but this is pretty well just going to go into the impact of rate of gain during that growing phase, whether in confinement or on pasture, and what that's going to do to finish performance of these cattle. Okay, any questions? Cool.